All right, welcome back. So we're going to take and do this problem. This is number 30 in 10.7. And we're going to find a vector function that represents the curve of intersection of the semi-ellipsoids. This is the top half of the ellipsoid. Okay, x squared plus y squared plus 4z squared equals 4. And the cylinder x squared plus z squared equals 1. Okay, so there's a couple things to sort of keep in mind here. One, when we look at sort of cylindrical or circular motion, we've already talked about it sort of in the 9.1, 9.2 stuff, and I'm going to talk about it a little bit more. But circular motion is best defined with sine and cosine. Okay, so first thing I'm going to do, I'm going to be like, okay, let's let x of t equal sine of t. Z of t equal cosine of t. And that's going to define this cylinder. Okay? Keep with me, okay? All right, now, those are off to the side. I may not use those, but that's a nice way sort of to think about that cylinder. And then y of t is going to be something else. Now, what I'm going to do, I'm going to plug this into here. Okay, so if I do that, take these together. Put them in blue. Put this up here. And what I'm going to see is, you know what? I'm going to insert this into here. If I do that, what am I left with? Well, y squared plus 3z squared equals 3. Okay, what am I doing here? Basically, I'm taking this first equation and I'm writing it x squared plus z squared plus y squared plus 3z squared equals 4. And I have x squared plus z squared equals 1. Okay, and I'm just subtracting it off. Okay, this is where y being greater than or equal to 0 sort of helps me out. I'm going to solve for y. Y equals the positive square root of 3 minus 3z squared. But what's z? Cosine of t. Let's cap that. Ah, there, you know what I mean. Ah. But wait, 1 minus cosine squared is sine of t, right? But I'm going to use absolute value. Why? Because it's got to be positive. Oop. Okay. Ta-da! All right. Now, next thing that we're going to talk about, next thing we're going to talk about is equations of tangent lines. Okay, so let's see. Let me scroll down to a problem here. Oh, I don't got a good one, so let's just take one out of the book here. Let's take, this is 36. And we have r of t equals e to the t, e to the negative t, 0. And it's going to say, find the equation of the tangent line. Well, this is not really that problem, but it's going to be the one that I'm going to do. Let's say t equals 1. So this isn't really 36. This is just inspired by. Okay. we're going to find the equation of the tangent line as t equals 1. What do we need for the equation of the tangent line? We need a point and we need a direction, right? So a point, r of 1. R of 1 is going to equal e 1 over e 0. What's the direction? Well, we need r prime of 1. R prime of 1 is what? Well, let's take r prime of t first. E to the t, negative e to the negative t, 0. So r prime of 1 is going to be e negative 1 over e 0. So the equation of the tangent line at t equals 1 is going to be this e from here, this 1 over e and 0, plus t e negative 1 over e 0. This is not r of t. This is the equation of the tangent line. So let's call it something else. Let's call it tangent line of t. Okay? All right. I'll see you all in the next video.